The creation of the perfect coin in 1700 does not begin with the strike of a die, but in the suffocating heat of the melting house, where the air is thick with the acrid stench of charcoal sulfur and the metallic taste of vaporized silver. Here, the struggle is chemical and elemental, a dangerous dance to ensure that every single ounce of metal meets the strict sterling standard of 92.5% purity. The process starts with a chaotic mix of raw materials, foreign reals, worn-out local currency, and tarnished plate, dumped into massive wrought iron pots nestled within furnaces, roaring at temperatures exceeding 1,700 degrees Fahrenheit. The melter, his face shielded by heavy leather but still scorched by the radiant heat, works a long stirring rod through the bubbling, blindingly bright liquid, skimming off the dross that floats to the surface like dirty cream. It is a sensory assault. The roar of the bellows driven by laboring apprentices drowns out all speech, forcing the master melter to signal with hand gestures when the silver has reached that terrifying, perfect fluidity required for casting. Once the molten sea is calm, the critical moment of assaying arrives. A tense pause in the physical labor, where precision dictates the fate of the entire batch. The master assayer draws a tiny sample from the glowing crucible, cooling it instantly to test its fineness against the trial plates kept under lock and key by the crown. There is no room for error here. If the mixture is too rich, the mint loses money. If it is too base, the mint master risks his reputation and, in severe cases, his liberty. Only when the nod is given do the workmen, sweating profusely in their heavy aprons, tilt the massive pots using a crane and tackle system, pouring the lethal, glowing syrup into upright iron molds. The sound of the pour is a heavy, liquid hiss, followed by the groans of cooling metal contracting in the molds. The danger is omnipresent. A single drop of sweat falling into the molten silver could cause an explosive reaction, scattering blinding shrapnel across the stone floor. As the iron molds are opened, they reveal the first tangible form of the future money. Heavy, dull ingots of silver, roughly 2 feet long and an inch thick, still radiating a dangerous heat. These bars are not yet coins, but they carry the chemical soul of the currency, having survived the trial by fire. The workmen seize these bars with long tongs, quenching them in water with a violent hiss of steam that fogs the room, before scrubbing them with sand to remove the surface oxidation. At this stage, the metal is brittle and stubborn, its crystalline structure stressed by the casting. Before it can be shaped, it must be inspected for air bubbles or hollows, hidden defects that would ruin a coin press later down the line. The rejected bars are thrown back into the inferno, while the perfect ingots are stacked like heavy bricks, ready to be transported to the mill room where brute force will transform this thick bullion into the delicate canvas required for the coining press. Leaving the melting house, the silver ingots enter the domain of the mill, a place where the floor vibrates with the rhythmic thumping of heavy machinery and the groaning of massive oak beams. This is the heart of the modernization of 1700, replacing the ancient and inconsistent hammer with the relentless precision of the rolling mill. The power source is often unseen but felt. A team of heavy draft horses walking in endless circles in a cellar below, or a massive water wheel churning outside, driving a vertical iron shaft that pierces through the floor to turn the heavy gearing above. The mill itself consists of 2 massive cylinders of hardened steel, polished to a mirror finish, set within a rigid iron frame. The gap between these rollers is the arbiter of the coin's destiny. It must be adjusted with agonizing precision using large screws, for if the silver strip is a fraction of a millimeter too thick, the coin will be overweight, and if too thin, it will be rejected as light. The operation requires a coordinated team of strong men who feed the silver ingots into the iron jaws of the mill. The metal screams as it is forced between the rollers, the immense pressure elongating the short, thick ingot into a long, ribbon-like fillet. This is not done in a single pass. The silver work hardens and becomes brittle under the stress, requiring it to be annealed, heated and cooled repeatedly between passes to regain its malleability. With each pass through the mill, the rollers are tightened slightly, stepping down the thickness of the metal until it exactly matches the gauge of a crown, a shilling, or a sixpence. The friction generates intense heat, and the smell of hot oil used to lubricate the gudgeons mixes with the metallic scent of the stretched silver. The men must feed the metal perfectly straight. A slight angle would cause the strip to curve and buckle, jamming the machine and potentially shattering the expensive steel rollers, which were difficult to manufacture and nearly impossible to repair. By the time the ingot has been transformed, it is a long, wavering strip of silver, several feet in length and uniform in thickness to the very edge of human perception. This uniformity is the defining characteristic of the new machine-made money, a stark contrast to the lumpy, uneven, hammered coins of the previous century. The fillets are laid out on long wooden benches where the master of the mill checks the gauge with a specialized caliper. Any section of the strip that fails the measurement is chopped off and sent back to the melting pot, a costly redundancy that keeps the standards high. The floor is littered with metal dust and scraps, which are swept up with religious zeal at the end of every shift. In this business, even the dust on a worker's shoes represents a significant value. The flat, polished strips now look more like raw material for industry than money, awaiting the violence of the punch that will give them their circular destiny. In the cutting room, the auditory landscape shifts from the low rumble of gears to the sharp staccato impact of metal shearing metal. Here, the long silver fillets are fed into a screw press specifically designed for cutting, known as the coupoir. The machine is a vertical screw mechanism with a sharp, cylindrical punch at the bottom, perfectly sized to the diameter of the intended coin. The operator sits before the machine, his concentration absolute, as he slides the silver strip over the hollow die. With a swift, rhythmic swing of the weighted horizontal arm, or by the pull of a lever, depending on the specific setup, the screw drives the punch down with crushing force. There is a sharp crack, and a perfect circle of silver, known as a planchet or blank, drops into a leather bucket beneath the bench. The operator must then immediately retract the punch and advance the strip, aligning it so close to the previous hole that only a honeycomb of thin metal remains, minimizing waste without ruining the next cut. This work is physically exhausting and surprisingly delicate. The cutter must maintain a rhythm that maximizes output while ensuring the punch does not overheat or chip against the die. A dull punch results in ragged edges or bent blanks that will jam the edge-marking machines later. The speed is dictated by the operator's stamina and the sharpness of his tool. As the blanks accumulate in the bucket, they jingle with a resonant, clear, bell-like tone, a sound that brings satisfaction to the workers, as it indicates the integrity of the metal. The leftover perforated strips, known as sisal, are bundled up like lace ribbons of scrap silver. This sisal creates a massive logistical loop. Often more than a third of the silver cast into ingots ends up as sisal, needing to be weighed, accounted for, and sent back to the melting house to be recast, creating a perpetual cycle of production and recycling that the mint clerks monitor with hawk-like suspicion. The human element here is critical. A moment of distraction can cost a worker a finger, crushed under the descending steel punch. The repetitive motion leads to a trance-like state, broken only when the punch needs to be swapped or the fillet runs out. Once the buckets are full, the blanks are taken to the weighing room. Unlike the finished coins, which are weighed in bulk, these raw blanks are often checked individually or in small stacks by the justifiers to ensure the rolling mill did its job correctly. A blank that is too heavy must be filed down, a slow, manual process called adjusting, while a blank that is too light is condemned to the melting pot immediately. The pile of dull, gray discs in the leather bucket is now uniform in weight and size, but they are still just lifeless slugs of metal, awaiting the specialized treatments that will prepare them to receive the king's image. The freshly cut planchets are chemically exhausted. The violence of the rolling mill and the trauma of the punch have compressed their grain structure, making them hard and brittle. If struck now, the dies would shatter, or the image would be ghostly and faint. To restore their malleability, the blanks must return to the fire, but with a gentler touch than the melting house. They are shoveled into large copper pans and placed into annealing furnaces, where the heat is carefully regulated to bring the silver to a dull, cherry-red glow without melting it. It is a game of timing played by the eye of the foreman. Leave them too long, and they blister. Pull them out too soon, and they remain too hard. Once removed, they are air-cooled, effectively resetting the metal's internal structure, making it soft and receptive to the die. However, this heat brings the copper content of the alloy to the surface, turning the once shiny silver discs into blackened, oxidized slugs that look nothing like valuable currency. To reveal the sterling beauty hidden beneath this ugly oxide skin, the blanks undergo blanching, a chemical bath that acts as a controlled corrosion. The blackened discs are dumped into perforated ladles and plunged into boiling cauldrons of water mixed with alum, tartar, or a weak solution of aquafortis, nitric acid. The workshop fills with a sour, biting steam that pricks the lungs and waters the eyes. The acid eats away the surface copper oxide, leaving a microscopic layer of pure, porous silver on the exterior. This process, known as pickling, relies on ancient chemical knowledge, transforming the dirty, dark metal into a brilliant, frosted white. The change is sudden and magical. As the ladle is lifted from the bubbling vat, the coins glisten with a snowy, artificial whiteness that signifies they are ready to become legal tender. The final step in this preparatory phase is drying, a low-tech but essential task to prevent spotting or staining. The wet, blanched blanks are tossed into large wooden troughs filled with dry sawdust, typically from elm or oak, as these woods are less resinous and won't leave a sticky residue. Apprentices, often young boys with sleeves rolled up, scour the coins in the wood shavings, rubbing them together until every drop of acidic water is absorbed, and the surface is polished to a soft sheen. The sound here is a constant, dry rustling, like walking through autumn leaves, punctuated by the metallic clinking of the silver. Once dry, the blanks are sieved to separate them from the sawdust. They emerge pristine, soft, and chemically stable, but they are still faceless discs, waiting for the two most crucial mechanical interventions that will define their value and security. Before the face of the king can be stamped, the edge of the coin must be armored against the greatest scourge of the currency, clipping. For centuries, rogues would shave slivers of silver from the edges of hammered coins, stealing the value while passing the diminished coin on. The solution in this era is a marvel of engineering kept under strict secrecy. The edge-marking machine, often based on the design by Jean Castaing. In a secluded section of the mint, the blanks are fed into a device that looks deceptively simple, but operates with crushing precision. The machine consists of two steel bars parallel to each other, one fixed firmly to the table, the other capable of sliding via a crank and gear mechanism. Engraved into these bars is the legend, such as Decus et Tutamen, an ornament and a safeguard, or a complex graining pattern. The operation is smooth, but demands high torque. The operator places a blank horizontally between the two steel bars. With a turn of the crank, the moving bar forces the coin to roll forward, squeezing it against the fixed bar. The pressure is immense, enough to imprint the lettering into the rim of the coin while simultaneously upsetting the metal slightly to create a raised rim, which will protect the future face of the coin from wear. This process happens in a blink. The blank rolls through the channel and drops out the other end, now bearing an inscription that is impossible to replicate without this heavy, specialized machinery. The existence of this edge lettering is the definitive line between the old world of hand hammering and the new world of mechanized security. It makes the coin a closed system, where any attempt to shave the metal immediately destroys the inscription and reveals the fraud. The rhythm of the edging room is distinct, a mechanical clack-whir-clack as the bar slides and returns. The workers here are trusted men, for they handle the blanks at a stage where they are nearly finished money. They must ensure the feed is constant and that the pressure plates do not slip, which would smear the lettering and ruin the blank. If the pressure is too high, the blank will warp into an oval. If too low, the letters will be illegible. It is a delicate balance of brute force and calibration. A pile of edged blanks looks different. They stack perfectly straight now, the raised rims interlocking slightly, creating stable columns of silver that feel substantial and engineered in the hand, ready for the final violence of the great press. The climax of the entire manufactory is the coining press room, a hall dominated by a row of massive cast-iron screw presses, anchored into stone foundations to absorb the shock of production. This is where the blank becomes a coin. The press is a giant vertical screw, topped with a heavy horizontal flywheel consisting of two long iron arms weighted with lead bulbs at the ends. At the center of the press, the upper die, the obverse, usually the monarch's head, is fixed to the bottom of the screw, while the lower die, the reverse, the shield or value, is set into the anvil block below. The power source is human, but it is raw, explosive kinetic energy. A team of laborers, known as spinners, stands ready at the arms of the flywheel. Their job is not to push, but to whip the heavy arms with a violent, coordinated swing to drive the screw down with tons of accumulated force, and then catch the rebound to reset it for the next blow. In the center of this whirlwind of swinging iron sits the moneyer, the most nervy man in the mint. He sits in a small pit or hole in the floor directly in front of the dies, his eyes fixed on the striking point. With his right hand, he flicks a fresh blank onto the lower die. With his left, he flicks away the finished coin from the previous strike. He must synchronize his movements perfectly with the rhythm of the spinners. If he is too slow, the descending upper die, moving with enough force to crush bone into dust, will take his fingers. It is a terrifying cadence. Swing, thud, flick, flick. The impact of the dies creates a deafening boom that reverberates through the building, followed by the ringing of the struck coin. The pressure causes the cold silver to flow like clay, filling every microscopic detail of the engraved dies, raising the king's nose, the curls of his wig, and the lettering in high relief, all in a fraction of a second. The physical toll is immense. The spinners work in short, intense bursts, their shirts soaked in sweat, their muscles straining against the inertia of the flywheel. They rotate out every 20 minutes to prevent fatigue. For a tired spinner means a weak strike, resulting in a weak strike coin, where the details are soft and unacceptable. The moneyer, meanwhile, enters a trance of dexterity, his life measured in the 2-second intervals between strikes. When the rhythm is perfect, a single press can strike a coin every 2 seconds, creating a glittering stream of wealth that flows into the receiving baskets. These are no longer metal slugs. They are now sovereigns, crowns, or shillings, imbued with the authority of the state, crisp, sharp, and identical to one another, a feat of standardization that was technically impossible just a few decades prior. The coins are now physically complete, gleaming with the fresh luster of the strike, but they remain legally in limbo until they pass the gauntlet of the final weigh-in. The output of the press room is not counted coin by coin, but weighed in bulk batches known as journeys, typically 15 pounds of silver or 701 sovereigns. The master of the mint's clerks place these heavy bags onto massive precision beams suspended from the ceiling. The tolerance allowed, known as the remedy, is razor-thin. A journey weight cannot deviate by more than a couple of pennyweights from the standard. If a bag is found to be too light, the moneyers are personally liable to make up the difference in silver. If it is too heavy, the coins are ruthlessly returned to the melting pot to be recast, preventing the crown from giving away free silver. This bulk weighing ensures that while individual coins might vary microscopically, the currency as a whole maintains an unshakable mathematical consistency that anchors the national economy. From every journey weight accepted, a single coin is snatched at random and dropped into a small, iron-bound wooden chest known as the pyx. This box is more than a container. It is the physical guarantee of the nation's honesty. Once filled, the box is sealed with 3 separate keys held by 3 different officers: the master, the warden, and the comptroller, meaning no single man can access the contents alone. Periodically, these coins face the trial of the pyx, a judicial ceremony where a jury of independent goldsmiths acts as the ultimate auditor. They melt down these sample coins to assay their purity and weigh them against the standard trial plates. The atmosphere during a trial is tense, for if the coins in the pyx fail the test, the master of the mint faces severe penalties, ruinous fines, or imprisonment for debasing the currency. It is a system of checks and balances designed to ensure that the coin in a farmer's pocket is chemically identical to the standard kept in the royal treasury. When the coins finally leave the mint, packed into heavy canvas sacks and loaded onto guarded wagons, they enter a world accustomed to the irregular, worn and clipped shapes of the past. To the person who receives one of these new milled coins in change, the experience is startlingly tactile. The edges are sharp and crisp. The lettering on the rim acts as a jagged grip against the fingers, and the relief of the monarch's head is high and distinct, catching the candlelight in a tavern or the sun in a market square. There is a specific, high-pitched ring when the coin is flipped onto a counter, a sonic signature of solid, uncracked metal that a cast counterfeit cannot mimic. This object is no longer just a piece of silver. It is a manufactured precision instrument of trade, a survivor of fire, acid, and crushing force, designed to circulate for decades without losing its integrity, carrying the weight of the era's industrial ambition in a disc no larger than a thumb. A coin is more than currency. It is a piece of history that has survived the fire to reach your hand. Ensure these stories survive just as long. Subscribe to support our work. Share this with a friend who values true craftsmanship. And tell me in the comments, what is the oldest date on a coin you have ever found? I read every response.